Modulus of a complex number. In last class we have seen how to find the conjugate, and with this conjugate we have found some results. Today we are going to see the topic modulus of a complex number. What is it, modulus of a complex number? It is nothing but, first we take a complex plane. This is origin, this is x, real axis, this axis is y, imaginary axis. I am plotting one point here. This is P, coordinate is what is that, x comma y. Isn't it? What is here modulus of a complex number? It is nothing but it measures the distance of this number from the origin. Okay. What is this? Root of x square plus y square. This is y. This is x. The length of this axis is x. This one is y. This is known as the hypotenuse. It is known as the hypotenuse. The modulus of a complex number is nothing but it measures the distance of that number from the origin in a complex plane. This side is known as the x-axis. The length of this x-axis is x. The length of the y-axis is y. Okay. How to find that complex modulus? See, it is a complex number. Z equal to x plus iy. The modulus of a complex number is denoted by mod z. For that, we have to find root of x square plus y square. This is the modulus of a complex number. Suppose if you are squaring on both sides, modulus z square is equal to x square plus y square. Okay, this is the complex number. The modulus of this complex number is denoted by mod z, root of x square plus y square. Taking square on both sides, modulus z square is equal to x square plus y square. Now, first we see the properties of this modulus of a complex number. What is the first property? Properties of a modulus of a complex number. First one, what is that? Modulus z is equal to modulus z bar. First property is modulus z equal to modulus z bar. Just take z equal to x plus iy. We find the modulus z for this root of x square plus y square. Then z bar, what is that? X minus iy. For this, we are to finding that modulus z. Here also we get root of x square plus y square. Okay. So modulus z is equal to modulus z bar. Second one, modulus z1 plus z2 less than or equal to modulus z1 plus modulus z2. This is called triangle inequality. Later we discuss this. Third one, modulus z1 z2 is equal to modulus z1 modulus z2. Then fourth one, modulus z1 minus z2 greater than or equal to modulus z1 minus modulus z2. Modulus z1 by z2 is equal to modulus z1 by modulus z2. Here modulus z2 is in denominator, na? So z2 should not be equal to 0. Then modulus z power n is equal to modulus z whole power n. Here n is an integer. Then real part of z less than or equal to mod z. Imaginary part of z less than or equal to mod z. These are all the properties of a modulus of a complex number. by using this property, we can see some sums and proof of the properties. Okay. First one, property triangle inequality. Let Z1 and Z2 be any two complex numbers. Any two complex number. Already we have seen this property in properties of a modulus of a complex number. What is that? Mod of Z1 plus Z2 less than or equal to mod Z1 plus mod Z2. We have to prove. We have to prove mod Z1 plus Z2 less than or equal to modulus Z1 plus modulus Z2. Proof. I am going to take this LHS. Modulus Z1 plus modulus Z2 whole square. I am going to write what is that modulus Z square? Z bar. We get Z bar. So I am going to write what is this? I am going to consider this as Z. So Z into Z bar. Using by this property. Using by this property. Now I am going to split this by using this property. Z1 plus Z2 whole bar is equal to Z1 bar plus Z2 bar. Using this property, I am going to write here. This. Okay. Then I am going to multiply 1 by 1. Z1 bar plus Z1 Z2 bar plus Z1 bar plus Z2 bar. See here a plus b whole square is equal to a square plus b square, like we brought it now. So what we have to do, a plus b whole square is equal to a square plus b square, like we have to bring. The like the same, isn't it? But it is plus 2ab it will come. Okay, we have to prove like this. So we have to bring like this. Here a plus b whole square is equal to a square plus b square plus 2ab. See, this is modulus Z1 square plus, here we have to bring 2 into a into b. Suppose if I am considering this a and this is b, means here to bring 2 into a into b. For that what I am doing now? See, you just keep this as it is. Here, suppose if I am going to take bar, whole bar. See the Z bar of bar is Z2. Z2 bar. For that bar, if you are finding means Z2, this is Z1. Small modification, I have done this. Why? Because the real part of Z less than or equal to Z. We have to bring this. By using this property, see here 2 times real part of Z, isn't it? Modulus Z1 square plus 2 times real part of Z1 Z2 bar plus modulus Z1 Z2 square. Here we wrote true real part now, so here we have to write less than or equal to modulus Z1 square. 2 real part of Z1 Z2, we can write modulus Z1 modulus Z2. Why? Because modulus Z bar is equal to modulus Z. Modulus Z bar is equal to modulus Z. By using this property, I am writing here modulus Z2 square. Okay, see this is a square plus 2ab plus b square. So I am writing like this whole square. Okay, here we have taken the square, so we have bring this value that powers also square. So from this we can able to write modulus z1 plus z2 less than or equal to, you take square root on both sides, you get, this is known as the triangle inequality. Okay, this is known as the triangle inequality. Here you just think nothing, you just take square. Suppose if you are taking square, this is equal to modulus z square is equal to z into z bar. Then by using this property, I split this bar for each and every complex number. z1 plus z2 into z1 bar plus z2 bar. Third step, I multiplied 1 by 1, I got this. Here z bar is equal to modulus z square plus z1 z2 bar plus, here for our convenience I just modify that z2 z1 bar to z2 bar of bar z1 plus mod z2 square. So see this is z1. How I wrote this 2 real part of z now? You just take this part. Whole term, isn't it? How I wrote 2 real part of z? We know z plus z bar by 2 is equal to real part of z. We know this now? You see here, z plus z bar is equal to 2 real part of z. How? See here, I am considering this z1 z2 bar plus z2 z1 bar whole bar. See, I am taking this z. So here the same bar we are having. So z bar is equal to 2 real part of z. So that's why I brought here. Okay. Then this real part of z less than or equal to modulus z. So I wrote this. This is the proof. Hence proved. Next one, geometrical interpretation. See, for this I am taking one origin. This is one vertices. This is another one vertices. Just to think about this. This is a triangle, isn't it? This is z1. This is z2. They have given like in your book. To finding the length of this line, it will come modulus z1 plus z2. But it should not be greater than the sum of the remaining two sides. Okay, that is the geometrical representation. Here they have given this is the reason it is known as the triangle inequality. How? See, 0, z1 and z2 are the vertices of the given triangle. Suppose if you are finding the length of this line, it will be modulus z1 plus z2. Na? Usually we are doing like this. Na? In vector also we can do that. Here, suppose if you are finding this modulus z1 plus z2, it cannot be greater than the sum of the remaining two sides. What is that meaning? Modulus z1 plus z2 cannot be greater than means compulsory it is less than this the sum of the remaining two sides. This is the meaning. This is the reason for calling this property is triangle inequality. Why? Because here less than or equal to it is coming. Suppose this equal to means we can tell it is equality, but it is not equal here. So that's why it is known as the triangle inequality. It can be generalized by means of mathematical induction to finite terms. How? Modulus z1 plus z2 plus zn less than or equal to modulus z1 plus modulus z2 plus modulus z3. It will up to n. The n value is n is equal to 2, 3 and so on. Okay. This is the triangle inequality. Then property. Next one, the distance between 2 points. The distance between the two points z1 and z2 in complex plane is modulus z1 minus z2. Modulus z1 minus z2. If z1 is equal to x plus iy, z2 is equal to x1 y1, x2 plus I y2. We want to find z1 minus z2 first. See x1 plus I y1, you just write the values minus x2 plus I y2. See what it will come, x1, you just write that imaginary and real parts plus I into y1 minus y2. Then we have to find the modulus. What it will come, we have to square x1 minus x2 whole square plus y1 minus y2 whole square. This is the distance between 2 points z1 and z2 in complex plane means this is the formula. Okay, next from this we can take 3 properties. Already we have seen modulus z1 plus z2 less than or equal to modulus z1 plus modulus z2. See, modulus of modulus z1 minus modulus z2 less than or equal to modulus z1 plus modulus z2 less than or equal to modulus z1 plus modulus z2. See, this is the triangle inequality, this is known, but if you are finding the modulus of modulus z1 minus z2, it is less than this value. Okay, one more thing. The same modulus of z1 minus z2 less than or equal to z1 minus z2 less than or equal to modulus z1 plus modulus z2. By using these results, we are going to find some values in this exercise. Now, property. Next one. Modulus of the product is equal to the product of mod. See what is this? Mod z1, z2 is equal to, but their modulus z1 plus z2 less than or equal to, that's why it is known as the triangle inequality. Here modulus of the product modulus of the product is equal to the product of modulus. This is the meaning of here, isn't it? Proof. See, modulus Z1. I am going to take LHS. Modulus Z1, Z2. I am taking square. See what is that? Modulus Z square means Z bar. By using this property, Z1, Z2 into Z1 bar, Z2 bar. Here, modulus Z1, Z2 bar means, oh, first we have to write whole bar, then by using this, we have to split this. See, by computative result, what is that? Z1, Z2 bar is equal to Z2 bar, Z1. Otherwise, Z1 bar, Z2 is equal to Z2, Z1 bar. See, for this Z2, Z1 bar, I am going to write Z1, Z1 bar, Z2, Z2 bar. Now, for these two, we can able to write like, see, modulus Z1, Z2 whole square. Suppose if we are finding square root, we get modulus Z1, Z2 is equal to modulus Z1, modulus Z2. Okay, this is the property, hence proved. It can be generalized by means of mathematical induction to finite terms. How? We'll see. See, modulus of Z1, Z2, Z3 up to Zn is equal to mod Z1, mod Z2, mod Z3 up to mod Z2. Okay, here what is that? That is the modulus of a product of a complex number is equal to the product of the modulus of a complex number. Isn't it? This is the thing I have mentioned here. Now we are going to see the example 2.9. Here they have given if Z1 is equal to 3 plus 4i, Z2 5 minus 12i and Z3 6 plus 8i. We have to find modulus Z1, modulus Z2, modulus Z3, then modulus of Z1 plus Z2, Z2 minus Z3, modulus of Z1 plus Z3. See, we have to find the values of modulus of Z1, modulus of Z2, modulus of Z3, modulus of Z1 plus Z2, modulus of Z2 minus Z3 and modulus of Z1 plus Z3. First I am going to find modulus of Z1. For that, Z1 is equal to 3 plus 4. What is that modulus of Z1? Already we have seen, we have to find the sum of the squares of the A and B. 3 square plus 4 square. What is 3 square? 9. What is 4 square? 16. So root 25 is equal to 5. Then modulus Z2. Five minus 12i. Modulus Z2 is equal to root of 5 square plus 12 square. What is that 5 square? 25. What is this 12 square? 144 is equal to 169 is equal to 13. Okay, then Z3. What is that Z3? 6 plus 8i. modulus Z3 is equal to root of 6 square plus 8 square. What is the 6 square? 36. 8 square 64 is equal to root 100. The value is 2. Next one, Z1 plus Z2. First we find, to find the modulus of Z1 plus Z2, first we find Z1 plus Z2. What is this Z1? 3 plus 4i plus 5 minus 12 Z2. Okay, we just add real and imaginary parts separately. 5 plus 3, 8. 4i minus 12i minus 8i. Okay, now you find modulus of Z1 plus Z2 is equal to root of 8 square plus 8 square. What it will come? 64 plus 64. Otherwise we can okay, you just do like the same. 128. What it will come? You just split this into terms. Otherwise we can 2 into 8 square. 8 square 8 it will come. 8 root 2 I think for this answer. Easily we can do. See, we can write 2 times of 8 square. It is the meaning. So for this 8 square, what is the square root? 8 root 2. Okay, next one, Z2 minus Z3. First you find Z2 minus Z3. What is that Z2? 5 minus 12i minus 6 plus 8i. You remove the brackets. 5 minus 12i minus 6 minus 8i. See, minus 1 minus 20i. Minus 20i. Now I am going to find Z2 minus Z3 is equal to root of, no need to bother about that sign here. Why? Because square root means square root of square we are finding, so that minus it will become plus. So you just write that number. 1 plus 400 root 401. One more thing we have to find. Z1 plus Z3. Modulus Z1 plus Z3. What is that Z1? 3. First you find is the sum of Z1 plus Z3. 4i plus Z3. What is that? 6 plus 8i. See, 6 plus 3, 9 plus 12i. Now you find modulus Z1 plus Z3 is equal to root of 9 square plus 12 square. 9 square 81, 12 square 144. 5, 225. For this 225, the square root is 15. Okay, this is the method. Suppose if you are getting a complex number, we have to find the modulus of a complex number, means this is the method. Next, example 2.10. Modulus of 2 plus I by minus 1 plus 2 plus I. We have to find the modulus value. See here what we are getting, modulus of Z1 by Z2, isn't it? What is the property? Suppose if you are getting like this, means we can split this. Here Z2 not equal to 0. So you just write that modulus separately. Now you find the value of modulus. What it will come? 2 square plus 1 square by 1 square plus 2 square. Root of 2 square 4 plus 1 by here 1 plus 4. Root 5 by root 5 is equal to 1. Next one, suppose if you are getting only I means, how can we find this modulus? This is I, we have to find the modulus means here there is no real part, so 0 plus 1 I. So 0 square plus 1 square, root of 1. So the value is 1. 12, we are getting 12. Here there is no imaginary part, so 0I, root of 12 square plus 0 square, root of 144 is equal to 12. Like suppose if you are getting any one real or imaginary parts, for that also we can easily find the modulus of a complex number. Now second option, in example 2.10, we got 1 plus I, the conjugate of 1 plus I into 2 plus 3I into 4I minus 3. First, we split these terms. How? Modulus of Z1, Z2, Z3 is their names. We can split this complex number like this. By using this property, I am going to split 1 plus I mod, modulus of 2 plus 3I, modulus of 4 minus 3. Next, we have to find the modulus of each and every one. For this, see, 1 minus I will come up. Conjugate if you are finding means 2 plus 3I, 4I minus 3. You just find the modulus separately. 1 square plus 1 square. See here 1 square. Here there is no coefficient. So we are considering it 1. Whatever the sign it is there, we just put plus into 2 square plus 3 square. 2 square plus 3 square into 4 square plus 3 square. 1 plus 1, 2. 4 plus 9, 13. 16 plus 9, 25. For this we can easily find the square root, 5. You just multiply these two, 26. 5 into 26. 13 into 2, 26. Third one. Third subdivision. Modulus of I into 2 plus I whole square by 1 plus I whole square. 1 plus I whole square. Just to see, by using this property, modulus of Z1 by Z2, I am going to write modulus Z1 by modulus Z2. First we split this I into 2 plus I whole square by 1 plus I whole square. By using this property, you just split this I 2 plus I whole square by 1 plus I whole square. Okay, by using this property, I change this. What is it modulus of I? Now only I told modulus of I means there is no real part, only imaginary part is there. So 0 square plus 1 square root 1 is equal to 1. 1 into root of 2 square plus 1 square by root of 1 square plus 1 square. 2 square 4 plus 1 by root 2. Root 5 by root 2. Root 5 by I left that square. Here one square it will come. Here I wrote, but here I left. See what it will come. 2 square 4 plus 1 whole square by 2 square it is coming here. Root 2 square. Root 2 square. Sorry, in some they have given here 3. But I have taken 2, that's why that answer is not coming to me. Now it is correct. See, root 5 whole cube by 2, this 2 and this square root it will be cancelled to 2. Here see, what is that? 3 is nothing but root 5 into root 5. For these two root 5, we can take 1 5 into root 5. 5 into root 5 by 2. I wrongly taken 2. That's why the answer is not coming. But in some they have given 3. Okay. 3 means this is the answer. One more time I will do for you. Why? Because I have done wrong there. See, you just split this. By using this property, then using this property, you split this 2 plus I cube plus 1 plus I square. This is the value is 1. Here root 2 square plus 1 square whole cube by root of 1 square plus 1 square whole square. Here they have given the powers. 5 power root 5 cube. Here root 2 square. This 2 and this root it will be cancelled, isn't it? How it will be cancelled? Root 2 square means it is nothing but we can change this to like. We can change this root like this. So it will be cancelled. Here root 5 by 2. For these two root 5, suppose if you are finding the product of this root 5, we get 5 into root 5 by 2. This is the answer for this. Next one, example 2.11. Which one of the points? They have given 3 points, I, minus 2 plus I and 3. Farthest from the origin, they are asking. Which one of the points, I, minus 2 plus I and 3 is the farthest from the origin. The distance between origin we have to find the distance between the origin to which point? They have given a I minus 2 plus I 3. See here we have to find the origin, means what is that Z? Mod Z mod I is equal to 1. First one this is. Then mod Z for second point. Minus 2 plus I is equal to root of 2 square plus 1 square. Otherwise you just take this is Z1, Z2. This is root 5. Z3 what is that? Just take a let Z1 is equal to I, Z2 is equal to minus 2 plus I, Z3 is equal to 3 for our convenience. 3 is equal to, what is this? Root of 3 square. This square and this square root it will be cancelled 3. So we can write, see what is this? 1 means where we will get, 1 is the x axis. There is no y axis, means here it will come. Isn't it? then root 5. Here also root 5 it will come somewhere. There is no imaginary part. Then the minus 2 they have given minus 2 plus I. See, this is 1. Here write as it is. I means here it will come. Minus 2 plus I means minus 1, minus 2 they have given. It will come 3. 3 is here. So this is one point. This is another one. This is third one. Which one is farthest from this origin? This 3. Why? Because 1 less than root 5 less than 3. 1 is less than root 5. Suppose if you are going to find root value of 5 means 2 2s are 4. So 2 point something it is coming. 1 less than 2.4, 2 point something less than 3. So this is the farthest point from the origin. Okay. If Z1, Z2 and Z3 are complex numbers given such that mod Z1 is equal to mod Z2 is equal to mod Z3 is equal to mod Z1 plus Z2 plus Z3 is equal to 1. They have given this condition. Find the value of mod 1 by Z1 plus 1 by Z2 plus 1 by Z3 is equal to what is that? They have to find. They have given mod Z1 is equal to mod Z2 is equal to mod Z3 is equal to modulus of Z1 plus Z2 plus Z3 is equal to 1. Since mod Z1 is equal to mod Z2 is equal to mod Z3 is equal to 1, I am taking this. See, first I am taking mod Z1 is equal to 1, squaring on both sides. I get mod Z1 square is equal to 1. What is that mod Z square? Z bar. So I am writing here Z bar is equal to 1. What we have to find the value of? Find mod of 1 by Z1 plus 1 by Z2 plus 1 by Z3. Isn't it? See, here we need the value of 1 by Z1. First you Z1 bar is equal to 1 by Z1. Similarly, Z2 bar is equal to 1 by Z2. Z3 bar is equal to 1 by Z3. We just take this 1 by Z1 plus 1 by Z2 plus 1 by Z3 is equal to, what is the value of 1 by Z1? Z1 bar plus Z2 bar plus Z3 bar. Z1 bar plus Z2 bar plus Z3 bar. Just take modulus on both sides. Modulus Z1, 1 by Z1, 1 by Z2 plus 1 by Z3. Modulus of Z1 bar, Z2 bar plus Z3 bar. By using Z1 plus Z2 plus Z3 bar is equal to Z1 bar plus Z2 bar plus Z3. I am going to write modulus of Z1 plus Z2 plus Z3 whole bar. One more thing, mod Z is equal to modulus Z bar, isn't it? So, what I am getting? Modulus Z1 plus Z2 plus Z3. So, the value is 1. Hence, that is true. Okay? So, the value is 1. Next one, 2.13. if they have given mod value, mod is equal to 2, show that three less than or equal to mod z plus 3 plus 4i less than or equal to 7. See here, they have given 3 less than or equal to mod z plus 3 plus 4i less than or equal to 7. Here, first you take these two. What is that? Mod z plus 3, isn't it? Now I am going to take this part first. Mod z plus 3 plus 4i. You just split this into two terms. Mod z plus 3 plus 4i. We know that value mod z equal to 2 given. So 2 plus, find this value, 3 square plus 4 square. Find the modulus of this complex number. 2 plus 3 square 9 plus 4 square 16 is equal to 2 plus 25. 2 plus 5 is equal to 7. 2 plus 5 is equal to 7. So you just take up. Why? Because already we told in a triangle inequality. Modulus z1 plus z2 less than or equal to modulus z1 plus z2. By using this property, I have written this. So here it has become less than or equal to. This value is 2. They have given in sum itself. Plus we have to find the modulus of this complex number 3 plus 4i, 3 square plus 4 square. So this is the answer. So modulus z plus 3 plus 4i less than or equal to 7. Now I am going to take this part. See, modulus z plus 3 plus 4i greater than or equal to. Suppose if here I am writing less than or equal to, means I want to write plus. Greater than or equal to means mod z minus mod 3 plus 4i. What is the value? 2 minus root of 3 square plus 4 square. 2 minus 25. 2 minus 25. 2 minus 5 is equal to 3. It is coming 3. Here minus 3 it will come. Suppose that greater than or equal to, you are changing means plus 3. Mod z plus 3 plus 4i less than or equal to 7. This is the answer for this. To find the lower and upper bound, we have to use the formula modulus of modulus z1 minus modulus z2 less than or equal to modulus z1 plus z2 less than or equal to modulus z1 plus modulus z2. Now we are going to see the example 2.14. Here they have given 3 vertices of the triangle. Show that their points 1 minus 1 by 2 plus I root 3 by 2 minus 1 by 2 minus I root 3 by 2. See, take one triangle. They have given 3 vertices. Here 1, here minus, name it A, B, C, minus 1 by 2 plus I root 3 by 2, minus 1 by 2 minus I root 3 by 2. We have to show the given points make a equilateral triangle. For that, we have to find the distance between the two vertices. What is that? Suppose if you are taking this Z1, Z2, Z3, we have to find the modulus of the distance. Modulus of z1 minus z2, z2 minus z3 and z3 minus z1. Suppose if the three values are same, it is equilateral triangle. Otherwise we can't tell the given triangle is the given vertices it is not making equilateral triangle. See, first take let z1 equal to 1, z2 equal to minus 1 by 2 plus I root 3 by 2, z3 is equal to minus 1 by 2 minus I root 3 by 2. Suppose if we have to show that the given vertices make a equilateral triangle, means we have to find the distance. Suppose if the distance, the values of the distance are same, it is a equilateral triangle. We'll see. The length of the sides of the triangle we have to find. The length, distance length, the length of the sides of the triangle. Triangle or length and distance are equal. See, length means this is the same, distance also same. Okay, first mod z1 minus z2. What is that mod z1? 1 they have given. See, 1 minus z2 minus 1 by 2 plus I root 3 by 2. Okay, minus into minus plus 1 by 2 plus I root 3 by 2. What it will come? Take 2 plus 1 3 by 2. It is coming like a 3 by 2. Just to separate you take here it minus it will come. Why? Because minus into minus plus, minus into plus minus. See, 2 plus 1 3 minus I root 3 by 2. Just to take a modulus 9 by 4 plus, otherwise you just write 3 by 2 whole square. It is very easy to do. Then next step we will find this root and this cancelled. So 3 by 2 plus here see this and this it will be cancelled. This 2 and this. So 3 by 4. 3 by. Otherwise you just do it directly. Suppose a shortcut method if you are using means we will do some mistake. 3 by 4. 4, 12. So root 3. It is very easy to us. Okay. First side is root 3. Second one. Mod z2 minus mod z3. Mod z2 what is that? Minus 1 by 2 plus I root 3 by 2 minus z3 minus 1 by 2 minus I root 3 by 2. Just to remove the brackets first. 1 by 2 plus I root 3 by 2 minus into minus plus 1 by 2 minus into minus plus I root 3 by 2. These two it will be cancelled. See here I root 3 by 2, here also I root 3 by 2. So 2 I root 3 by 2. These two it will be cancelled. Suppose if you are finding square means it will come like this square and this square root it will be cancelled root 3. For finding z3 minus z1, what it will come? Minus 1 by 2 minus I root 3 by 2 minus 1. Minus 1 by 2 minus here it will come up minus 1 minus I root 3 by 2. See, minus 2 minus 1 minus 3 minus I root 3 by 2. 9 by 4 plus 3 by 4. 12 by 4 is equal to 3. So, mod Z1, what is the final answer? The sides are equal. Mod Z1 minus Z2 is equal to mod Z2 minus Z3 is equal to mod Z3 minus Z1. Since the sides are equal. Since the sides are equal, so the given vertices surely make a equilateral triangle. Next one, 2.15. See here, they have given mod Z1, mod Z2, mod Z3 is equal to or greater than 0. And Z1 plus Z2 plus Z3 is equal to 0. We have to prove that modulus of Z1, Z2 plus Z2, Z3 plus Z3, Z1 by Z1 plus Z2 plus Z3 is equal to R. Given that, what is that? Given, see, mod Z1 is equal to mod Z2 is equal to mod Z3 is equal to R. You just take this mod Z1 is equal to R, squaring on both sides. See, modulus Z1 square is equal to R square. We can able to write Z1 bar is equal to R square, isn't it? So, Z1 is equal to R square by Z1 bar. Okay, similarly, we write Z2 equal to R square by Z2 bar. Z3 is equal to R square by Z3 bar. Next, Z1 plus Z2 plus Z3. We have to find Z1 plus Z2 plus Z3. What it will come? R square by Z1 bar plus R square by Z2 bar plus R square by Z3 bar. Okay, now I am going to find modulus of Z1. Both sides I am going to find the modulus. R square by Z1 bar plus R square by Z2 bar plus R square by Z3 bar. See, I am going to bring this R square commonly. One more thing, 1 by Z1 bar plus 1 by Z2 bar plus 1 by Z3 bar. See, take LCM. Here Z1 is there. So, without this Z1, remaining what are they? Z2, Z3 bar. Plus here Z2 bar. So, we have to write remaining. Z1 bar, remaining terms we have to write, plus Z3 is there, Z1 bar, Z2 bar. Here, modulus of R square, we can write this common one by using that property. Okay, suppose modulus Z bar is equal to modulus Z. So, R square by Z2, Z3 plus Z1, Z3 plus Z1, Z2 by Z1, Z2, Z3 Z1, Z2, Z3. It is coming here. See, for this what is the value? Here if you are finding this means R square it is coming. Z1, Z2 plus Z1, Z3 plus Z1, Z3 by R cube. Z1 is equal to R, Z2 equal to R, Z3 equal to R. So each and every number value is equal to R. So it is cancelled. What it is coming here? Modulus of Z1 plus Z2 plus Z3 is equal to modulus of Z1, Z2 plus Z1, Z3 Z1, Z2 plus Z1, Z3 plus Z1 Z2, Z3, Z1, Z3, Z1, Z2. Here only I wrote up. That's why it is not coming correctly. By modulus of Z1 plus Z2 plus Z3 is equal to 1. Is equal to, see here, this is not. So I change this. Okay. Show that the equation z square is equal to z bar has 4 solutions. It has 4 solutions. See, what is this z square? It has, we have to prove it has 4 solutions. See, just take both sides modulus. By using this property, we can write like that, isn't it? What is this modulus z square? Z bar. Modulus z square is equal to z bar. Already we have seen. See, z bar is equal to modulus z bar, it is coming. Otherwise, you just bring this side. Modulus z bar minus modulus z bar. Modulus z square. This I am going to write using by this property. This equal to 0. From these two, modulus z. Modulus z minus 1 equal to 0. See, either this is equal to, this is the, here we are getting 2 factors. One is modulus z, another one is modulus z minus 1. 2 factors here we are getting. Either this is equal to 0 or this is equal to 0. That time only, if you are finding the product of these 2 factors, we get the value is 0. So, modulus z equal to 0. One more thing, modulus z minus 1 equal to 0. See, modulus z is equal to 1. Suppose if you are, we are finding this one. Modulus z square is equal to modulus z. Modulus z square is equal to modulus z. You substitute this value. Here you get, we have to tell 3. We have to prove 4 solutions. Here 1 solutions we gave. One more thing, z square is equal to z bar. This z bar we can write 1 by z. Easily we can do this. Z bar can be write z bar is equal to 1. This z bar is equal to 1 by z. So z square equal to 1 by z. See, z cube is equal to 1. Here the value of the complex number getting the power is 3. So for this complex number, surely it will get 3 solutions. Already 1 solution is there, z. So just write that sentence. It has 3 solutions One more thing, including zero solution, totally it has 4 solution. You just see, this is very easy to do. One more time I will do for you. This is very important one also. See, just take modulus on both sides. Okay, here I am going to use this property. Modulus square is equal to modulus z. You bring this modulus z this side. Suppose if it is coming to left hand side, that sign will be changed 0. From these two, I am going to take one common mod z, remaining mod z minus 1 equal to 0. This is the factors of this equation, isn't it? Here, either this will be 0 or mod z minus 1 is equal to 0. See, mod z is equal to 1. The value of mod z equal to 1. Now I am coming to this. Z square is equal to z bar. We know z bar is equal to 1. So z bar is equal to 1 by z. Now I am going to substitute this 1 by z here. See, suppose if I am bringing this z to left hand side, the power it will be 3. So here it has 3 solutions. For this equation, but already we found mod z equal to 0, including this 0. 0 solution, it has 4 solution. It has 4 solution. Okay guys, thank you. You just practice well. Tomorrow we will see the next topic, square root of a complex number, and that exercise. Thank you.